Hi everybody, my name is Taylor Richardson and I'm going to be going over Module 4's exam for Chapter 6. Okay, and so we're going to get started with number 1. And this question was about the 4 shapes that are given and how to figure out the different fractions that they can represent for each other. And so you can see here that I drew out the base unit, and what we need to figure out first is the base unit, and that's which shape we're going to be using to figure out how many of the other ones can fit into it. And so first we see the base unit is the hexagon, and that there's one hexagon there. And so we're going to see how many trapezoids can fit into one hexagon. And so we can see by the picture I've drawn that 2 trapezoids can fit into one hexagon. And so one trapezoid represents 1/2 of a hexagon. And so in the same way, triangles also fit into hexagons. And so a triangle can fit into a hexagon 6 times. And so that means that one triangle represents 1/6 of a hexagon, meaning that all 6 triangles can fit into a whole hexagon. And then finally, the rhombus that's shown. One rhombus is equivalent to 1/3 of a hexagon. And this is a little different than how it's been fitting all nicely in the pictures shown. We can see that two rhombi fit nicely into the hexagon, and then one is split in half, and it's kind of put end on end, and 1/2's over here and 1/2's on the other side. And so that means that 3 rhombi fit into a hexagon. And so one rhombus is equivalent to 1/3 of a hexagon. And so it's the same with the rest. We'll start with the base unit of a trapezoid. One hexagon has 2 trapezoids in it. So one hexagon is that means that there is 1 hexagon for every 2 trapezoids, equaling 1/2. And for every 3 triangles, there is 1 trapezoid. And so that equals 3. And there's 1.5 rhombi for 1 trapezoid, because only half of the rhombus fits in that other little part of the trapezoid. And so it goes to the same for the triangle. There is 1 hexagon. For 1 hexagon, there are 6 triangles, and that means that they are 1/6 of a hexagon and 1/3 of a trapezoid, because there are 3 that fit into a trapezoid and 2 that fit into a rhombus, so 1/2. And the same goes for 1/2. Moving on to number 2, this question was about the man that bought the length of rope. And so we know, firstly, that he used 1/3 of the rope to make a bow painter. And so the rope that we are given at first, we're going to divide it into 1/3 that I have drawn here. And then we also know that he used 1/4 of the remaining piece to tie up a roll of carpet. So we're going to divide that piece into another 1/4. And so from then we know that we have 36 feet remaining. And so we want to know the length of the rope that he had before he cut it at all. And so to find this, we can take our 36 feet that we have, and we're going to divide it by 3 to get the remaining 3 sections to go with our 1/4 here. And so we find that the 36 divided by 3 is 12. And so this means that each section is 12 feet long. And so we can take the entire rope and we can divide it into 12 sections of 12 feet. And we can see that there are 6 sections of 12 feet, meaning that the rope originally was 72 feet long. And then moving on to question 3, this one was about the fraction functions. And we are going to represent their addition and subtraction, and we're going to solve them with these fraction strips and these number lines here. And so in order to do that, I like these because they're a nice visual representation of the addition going on. And so the first problem is 1/3 plus 1/2. And so we can see 1/3 represented here with the one part shaded in for 1/3 and then the 1/2 underneath it. And so these are helpful to be able to see the actual addition that's going on, but you still have to find the common denominator between the fractions, so you still have to do the work. And so we know that 1/3 is equal to 2/6 and 1/2 is equal to 3/6. And so we know that 2 plus 3 is 5. So since 2/6 plus 3/6 is 5/6, we know that 1/3 plus 1/2 is also equal to 5/6. And so we can see that there are 5 sections here shaded in, and there's one not to represent that 6. And we can see it represented there on the number line. And then part B is 1/2 plus 3/4, and we can see again the 1/2 shaded in and the 3/4 shaded in, and this equals more than one. It actually equals 5/4, which is also equal to 1 1/4, 1 1/4. And so this is represented by one whole strip shaded in, 4/4, and then 1/4 of another one shaded in. And then, so moving on to part C, this one was a subtraction problem. So part C and D were. And so this is done in the exact same way. We see our 3/4 minus 1/3 is the problem. And so we have our 3/4 right here shaded in, and then we have the 1/3, and we're going to subtract that by getting a common denominator. And we know that 3 times 4 is 12, and so that's going to be our common denominator because that's an easy one. And so 1 times 4 is 4, so we're going to have 4/12. And we're also going to have 3 times 3 is 9, and we're going to have 9/12. So we know that 9/12 minus 4/12 is 5/12. And so that's also shown on the number line there. And then the same method goes for part D. And then we are moving on to part 4, to number 4. And this one brings in multiplication. And multiplication is always scary when you bring it in after addition because that one's so easy. But this one is really just addition too. So the first part is 3 times 1/5, and we can easily figure this one out because we can make fraction circles, and fraction circles are just what they sound like. You make a circle and you're going to divide it into fractions. And what this problem is asking us to do is make 3 fraction circles that each represent 1/5. And so we see here there's 1/5. And there's 1/5, and there's 1/5, and we're going to add those together, and that gives us 3/5, and that is all that problem is asking us to do. So 3 times 1/5 equals this 3/5 right here. And so the same goes for part B, 3 times 2/4. You can see this 2/4 plus 2/4 plus 2/4, and that's going to give us 1 whole 4/4, 4/4, and then another 2/4. So this equals 6/4 or 1 1/2. And then the same goes for part C, 5 times 5/8. We see there's 5 fraction circles here, and they all represent 5/8. I had them highlighted all pretty, and then the scanner did not pick them up, so you got scribbles. And so we see this 5 times 5/8. We can see 5/8 plus 5/8 plus 5/8 plus 5/8 plus 5/8. And this equals, all in all, 25/8. And that is 3 whole 8/8, and that's 1/8 left over. So 3 1/8 is the answer there. And so the same applies when you turn it to a negative. So the question is -5 times 5/8. And so it's the exact same problem. You're going to work it out the exact same way, only the answer is going to be negative because you have the -5 right there. And so you're taking it away. And then we're moving on to number 5. And this one is fun because it has a nice little picture for you. And the goal here is to find what fraction gives the area of each piece. And so you see the sections A, B, C, D, E, F, and G here in the square that's given. And what we're going to do is we can see already that A and B, they're equal, and they take up 1/2 of this picture. And so since we know that they take up 1/2 and that they are equal to each other, that they each take up 1/4 of the whole square. And so we can see here, these are the answers given. Section A is equal to 1/4 square units here, and section B is also equal to 1/4 square units. And then section C is equal to 1/16, and section D is equal to 1/8, and section E 1/16, section F 1/8, and section G 1/8 square units. And so we can find this just how I found this A and B represented 1/2 of the square, and that they are equal so that they each represent 1/4 or 1/4. We're going to do the same by finding how many of each of the smaller squares can fit into each of the bigger squares. And so that's how you find each of the fractions for the area of each piece. And so we know that since sections D, F, and G, they represent 1/8. And we know that because here's section D, and we know that it can fit in this whole square 8 times. And the same goes for section F and section G. And then the same for 1/16. And so then part 6, number 6, this one's about making brownies. And so we have a problem. We're given an ingredient list or recipe, and it makes 16 brownies, but we only want to make 12. And so we need to figure out how we can divide up this recipe to only make 12 brownies instead of 16. So in order to do that, we're going to first need a fraction or something to divide by. So we're going to get this fraction by taking the 12 brownies that we want, and we're going to put that over the 16 brownies that we already are going to get. And so we know that 12 over 16 is equivalent to 3/4. And so we are going to divide everything in the recipe, divide it by 3/4. And so we know that 1/3 divided by 3/4 equals 1/4 cup of butter. And 3 times 3/4 is equal to 2 1/4 ounces of unsweetened chocolate. And 3/4 of a cup of sugar times 3/4 is equal to 9/16 cup of sugar. And 1 1/2 times 3/4 is equal to 1 1/8 teaspoon of vanilla. And 2 3/4 is equal to 1 1/2 eggs. And 2/3 times 3/4 is equal to 1/2 of a cup of flour. And so those are the answers for this exam, and I hope this was helpful. And so I will see you next time. Thank you. Bye.